In this lesson, we will discuss oxides of sulfur. Sulfur 4 oxide is readily generated by reacting sulfide salts with dilute hydrochloric acid.
The following video clip shows the preparation of sulfur 4 oxide. It is either prepared in a fume chamber or in open air. This is because sulfur 4 oxide is poisonous.
The following is the setup in preparation of sulfur 4 oxide. Not yet. Note the bubbles.
Anything happening there?
Yeah.
This side, anything happening?
Not yet. To chromate 6. Let the test it in. Note the color change of orange potassium dichromate 6.
Since sulfur 4 oxide is a reducing agent, it reduces the ions of manganese from orange to green. Since sulfur 4 oxide is a reducing agent, it reduces the ions of manganese from orange to green. The following video clip shows the preparation of sulfur 4 oxide. It is either prepared in a fume chamber or in open air. This is because sulfur 4 oxide is poisonous.
The following is the setup in preparation of sulfur 4 oxide. Sodium sulfite is placed in the round bottomed flask. Sulfur 4 oxide is bubbled through orange potassium dichromate 6. Dilute hydrochloric acid through the funnel into the flask to cover the sodium nitrite. Heat the flask gently to speed up the reaction.
Sodium sulfite reacts with dilute hydrochloric acid to form sulfur 4 oxide, sodium chloride and water. The gas is passed through concentrated sulfuric acid to dry it. It is then collected by downward delivery since it is denser than air. Orange potassium dichromate 6 paper turns green after some time, indicating the gas jar is full of sulfur 4 oxide. Note that sulfur 4 oxide can also be prepared by heating of concentrated sulfuric acid with copper tannings. The following are some of the physical properties of the gas. Is a colorless gas, has a characteristic irritating and choking smell, easily liquefied at 3 atmospheres. It is denser than air, hence collected by downward delivery. Reaction with water. Observe the animation below and note the water level rising in the gas jar, drop in water level in the trough, and blue litmus turning red. Note that the water rises rapidly in the gas jar, showing that the gas is highly soluble in water. The gas dissolves in water, forming an acidic solution known as sulfurous acid. Sulfurous acid turns blue litmus red. Sulfurous acid, like carbonic acid, cannot be isolated as it is readily oxidized to sulfuric acid. Sulfur 4 oxide, being acidic, is absorbed by sodium hydroxide solution to form sodium sulfite and sodium hydrogen sulfite. Observe the following animation and note the color of the flower petals at the beginning. The color of the flower petals changing white. In the presence of water, sulfur 4 oxide bleaches the colored flower petals by reduction. It reduces the dye by removing oxygen from it, hence flower petals change color from red to white. Note that in the absence of water, sulfur 4 oxide will not bleach the petals. Observe the following animation and note the color change of acidified potassium chromate 6 solution from orange to green. Acidified potassium dichromate 6 solution changes from orange to green. That is, the orange dichromate 6 ions are reduced to green chromium 3 ions. The overall reaction is written as follows. Note that this is the confirmatory test for sulfur 4 oxide gas. Observe the following animation and note magnesium catching fire on heating. Magnesium continuing to burn in sulfur 4 oxide, white powder forming on the spoon, and yellow solid deposited on the gas jar. Magnesium continues to burn in sulfur 4 oxide, forming white magnesium oxide and yellow sulfur deposits.